Hi friends, very good morning. I hope all you are well. Today we will discuss the AWS Elastic Load Balancer. For load balancer, few questions we had discussed in the previous slides as well in previous sessions. But in this session we will try to discuss more dig about the Elastic Load Balancer, like what is this, right? What are the types of ELB? What is listeners? Right, what is the difference between and why this ELB comes in picture. So for all these questions we will discuss the in today's session. Let's start the session. What is the role of listener in load balancer? On what basis listener is scattering the request? What are the types? So if we can see, there are three questions covered here. Point number one is what is listener, second is on what basis listener is scattering the request, and third is what are the types. So let's start with the definition. So a listener is the process that checks for internet connections request, right? That means whatever are the requests coming from the internet, so listener is actually listening, and he enables in such a way that so that he can cater the inbound traffic, right? For listener, there is no need to configure. It is a virtual inbuilt of LB. So listener is inbuilt feature of LB. No need to configure manually later on. Listener caters the request on the basis of port. Yes, this is the answer of your second question, which is asked here. On what basis listener is catering the request? So listener caters the request on the basis of port, right? It checks whether the request belongs to port HTTP, HTTPS, SSL, TCP, or what kind of ports they are requesting, and listener acts accordingly, right? So for example, if an HTTP connection is there, HTTPS connection is there, he just read the types of request and he directly lands on the application. And similarly for TCP and SSL. Now, what are the types of listeners? So here is the answer. There are two types of listener. Number one is forward listener. Second one is backward listener. Forward listener, these are placed on the internet side, having responsibilities of accepting the request. However, backward listener, it is in sync with the forward listener and passing the request to EC2 server to balance the traffic load. So backward listener is responsible to manage the traffic load in EC2 servers, right? See, a listener is a component of load balancer, right? So overall load balancer is managing everything, but if someone says what exactly in load balancer who is responsible to manage the traffic, that is the our backward listener. So backward listener is responsible to manage the traffic load in EC2 servers. Next slide, next question. Which technology you use for FT and HA? FT means fault tolerance. So, so to manage the fault tolerance and high availability, we need to insert the load balancer and auto scaling in our infra. Coming to the third question, guys, don't go for the number of questions here. That was actually mismatched, right? So this is the third question. Can we place load balancer between regions? Yes, very important question, guys. Regions means, as we know that AWS cloud just specify their regions, right? In terms of the regions, for example, Asia region, Europe region, North America region, South America region, Australia region. So these are the regions which is created by the AWS cloud. So the question is asking, does we place load balancer between the regions? Indirectly, this question is asking that can we, can we place one EC2 server in Asia and the second one in Australia and the third one is Europe, like that? Yes, we can do that by using of route number 53, which is DNS, but it is not recommended, right? Because because the time taken to serve the request would be very more. So it's recommended that you should uh, you should place all the EC2 servers in a specific region, or you can create a multiple availability zones. So we have options to place the load balancer between regions by using route number 53. Ideally, we use the load balancer within a single region for better performance, right? We can create, but for better performance, it's recommended that we should place the EC2 servers in a specific regions. Coming to the next slide, next question. What are the list of connections listeners is capable of handling, right? For example, um like how listeners is capable of handling the request, right? Under what layers these are working? Does ELB handling ICMP request at all? So in these questions as well, there are three questions involved, right? Number one is the capability, second one is the what are the layers they are working upon, and the third thing is that does ICMP request catered by the ELB or not. So question number one and two has been covered here, like HTTP which works on layer 7, HTTPS which is work on again layer 7, SSL and TCP work on layer number 4. So connect, so listener is catering these requests, right? These requests, and layer 7744, and if we talk about ELB, this one, sorry, ICMP, right? So ELB doesn't entertain ICMP, that is our ping request, right? If so someone needs to ping the servers, right, that request doesn't come from load balancer, right? It will connect directly because ping request doesn't catered by the ELB. I hope you got. Coming to the next slide, next question. Yes, this is scenario based question. Suppose you are handling a EC2 servers and pinged another server, right? Okay. Does this request also catered by ELB? Yes. This is the same question I just had discussed. Outbound traffic does not catered by ELB, right? Outbound means if request initiated by our server, that request does not catered by the ELB. Only request coming from the internet will be taken care by ELB, right? That means whichever are the request coming from the internet, that only request will be catered by the Elastic Load Balancer. Coming to the next question. Imagine you are admin and managing the LB. Okay, what happens if you delete the LLB? Is there any effect on EC2 instances which were placed behind ELB? Very important. Suppose you had deleted the LB. So is there any effect on EC2 servers for catering the services? The answer is post deletion EC2 instances starts scatter the traffic connections directly. Okay, but it's recommended to route the connections via route number 53 to map these instances with other balancers, load balancers. So the answer is saying that yes, we can run our EC2 servers without LB as well, but it's recommended to have the load balancer, and if you have deleted the load balancer, then it's again recommended to route route this one, route the traffic via load balancer to all this is EC2 means you have to run the EC2 servers by load balancer only by use number route number 53. Coming to the next slide, what is FT and how you create the application? So FT is a fault tolerance. It provides the availability when one or more hardware components fails in infra, right? AWS recommends to to just create at least two or more availability zones, attach is EC2 instances in these zones, and further connect to ELB. If one availability zone become faulty, then other availability zone is there to cater the services, and ultimately our system becomes fault tolerance, right? So FT is the fault tolerance as we have discussed, right? How you create for applications, guys. Fault tolerance means we have if our availability zone becomes faulty, na, then our services would not be hampered. We have to make our infra in such a way that if suppose one or more components failed in infra, then our services will not be failed, right? So we have to manage this. How we can manage? We can manage uh, via creating the availability zones. At least two or more availability zones should be there and attach these instances in these availability zones and further connect to ELB, right? This is answer. So I hope you like this video, guys. If you think that these videos are helpful, or if you have any queries in your mind in which you need me to answer your questions, right, request you to put your questions in comments. I will definitely try to cover those questions as well. Kindly hit the bell icon and don't forget to share. Thank you.